Welcome to section 8.4, page 1. This is our very last section of the year. I hope it's worked out okay for you. I've missed you guys. Hope you're all well. Postulate 22 says the ratio of the circumference of a circle to the length of its diameter is a unique positive constant. So what they're saying here is if you take their circumference, which is all the way around the circle, it's sort of like the perimeter of a circle, and you divide it by the diameter, which is through the center all the way across from end to end, that is equal to a number and the same number every single time for any circle. And what we find there, so let's go ahead and mark these things down. So this here is the diameter, okay? And then when we start and go like this, when we start, let's say here, and go all the way around here, that is called the circumference, okay? All right, now I don't know if you've ever tried this before, but if you take a can and you measure around the outside, and then you measure, so you'd have to have a bendable measuring tape, and then you measure across the center, the diameter, and then you take the circumference and divide by the diameter, you should get what's known as pi. That's the ratio between the circumference and the diameter. So pi equals circumference divided by diameter. And you may know that that's equal to 3.14 or 22/7. Or on your calculator, you'll have a button. So on this calculator here, it's right here, pi. Okay, so the theorem says if you're trying to find the circumference of a circle, it's equal to c equals pi d. How did they get that? Well, they used this formula here, multiplied both sides by d. The d's would cancel out here, and here you get pi d. So pi d equals c. Well, we also know the relationship between diameter and radius. If you take a look at this, the radius is from the center to the outside. That would be the radius. So if you put two together, you get the whole diameter. So either d or a 2r will give you the formula. So you can use whichever one is more convenient. So let's take a look at this problem. It says find the exact circumference. When they say exact, they want you to leave pi in the answer. Don't use 3.14, don't use 22/7, don't use a calculator. Just write pi in the answer. Okay, so we're finding the circumference of a circle whose diameter has length 10 inches. So it makes sense to use this formula here. So we're going to say c equals pi d. And then we're going to go ahead and put the 10 inches in. So pi and then 10 inches. Okay, so our answer is just 10 pi, and then the answer is in inches. So remember that circumference is like a perimeter. It's how far do you walk around. So the unit should be just inches, feet, nothing squared. Okay, let's try number 4. Find the approximate circumference of a circle whose diameter has length 20 centimeters. Use pi equals 3.14. Okay, so here the formula we're going to use, we have the diameter again, so pi d. And we're going to go ahead and put in, instead of pi, we're putting in 3.14. And for diameter, we're putting in 20 and centimeters. So go ahead and multiply this out. When you do that, you're going to get 6.80. If you, here, let's just show you on the calculator. So you get 3.14 times 20, and you get 62.8 or 62.80, and still we have centimeters. All right, that's it there. So how about the formula for the area of a circle? Well, here it's in terms of radius, and it's equal to a equals pi r squared. So in example 2 here, they've asked us to find the exact area, so leave pi in the answer, whose diameter has length of 10 inches. So when we look at the formula here, the area of a circle is pi r squared. So we have to have the r to put in here. So if we look at our circle, and we say this is our diameter. We know that that is 10 inches. But we need R right here. So what would that be? Half of 10, or 5 inches. So R equals 5 inches. That's what we want to put in. So A equals pi. We're supposed to leave pi as it is. And then 5 inches. Okay, so what do we get there? Well, pi. Oops, I forgot my little square sign. Okay, so 5 squared would be 25. And inches squared would be inches squared. So now we're talking about area, so our answer should be in square units. So we're not supposed to do anything with the pi, but I am going to turn it around and write 25 pi and then inches squared. And that's our final answer there. One last one here. We're supposed to find the approximate area of a circle whose diameter has length 20 centimeters, and we're supposed to use pi equals 3.14 here. So again, we're finding the area, so pi r squared. In for pi, I'm supposed to use 3.14. And what are we putting in for r? Well, again, let's take a look at the picture. Here's our circle. The diameter is 20 centimeters. So what would the radius be? Just half of that, 10 centimeters equals r. So I'm going to put in here 10 centimeters, and then I'm going to square it. So we have 3.14. 10 times 10 would be 100, and then centimeters squared. When I multiply 3.14 by 100, it just moves the decimal point over 2 places. So I have 314 centimeters squared. Again, area should have square units. And that's the end of page 1.